Imagine holding the Cambridge Examiner's red pen. Today, we're skipping the fluff and looking exactly at why so many hardworking IGCSE physics students face absolute devastation on their exam papers when it comes to electromagnetic induction, generators, and the national grid.
0 out of 4 marks. That is painful. This brutal score is the harsh reality for countless students who walk out of the exam hall feeling super confident, only to get totally crushed on results day. And why does this happen? Well, it's because they get the general vibe of the concept, but they use vague, everyday language instead of the hyper-specific physics terminology the mark scheme actually demands.
Okay, let's dive right into this. A student writes, "Water turns a wheel to make power." Honestly, it sounds perfectly logical if you're just chatting with a friend, right? But the examiner's red pen is just going to slash right through it with a note saying, "Missing electromagnetic induction terminology." And this right here is exactly why ordinary revision totally fails you. You can literally read the textbook 100 times over, but if you don't write the exact words the examiner is hunting for, you get a 0.
Section 1, the perfect answer framework. This is how we secure those top band marks every single time.
So, here is our 4-step perfect answer framework. Step 1, you identify the core concept. Step 2, pull evidence or data directly from the exam scenario. Step 3, apply your scientific reasoning. And step 4, honestly, the absolute most critical one of all, lock it in with exact examiner wording. That 4th step, that's your ultimate shield. It's the armor that literally stops the red pen in its tracks.
Let's move to Section 2, decoding power station schematics. We'll break this down component by component.
Let's map out the schematic of a coal-fired power station from the source material. Now, exactly how the thermal energy is produced might vary from plant to plant, but the core machinery, it remains identical. Let's trace the energy transfer mentally here. It starts way over at the boiler, moves right into the turbine, and finally, it hits the generator.
Let's start with that boiler. The exact, precise definition you need to know is this. A boiler is a device where thermal energy is transferred to water to turn it into steam. That is the crucial first step. The chemical energy from your burning fuel becomes thermal energy, which then heats up the water. Simple enough, right?
Next up, that incredibly high-pressure steam travels straight to the turbine. The definition the exam wants here is a device made to turn by moving air, steam, or water. This is where the real magic of motion kicks in. The steam forces the blades of the turbine to spin, transferring all that thermal energy directly into kinetic energy. And notice how it's linked by an axle straight to the next component.
And that next component is, of course, the generator. So the absolute crucial point is how you define this. A generator is a device which generates electricity using electromagnetic induction. Did you catch that phrase? Electromagnetic induction. This is where a voltage is induced in conducting wires when they move in a magnetic field. That exact phrase is the non-negotiable term the mark scheme demands. If you just write down, "it makes electricity," bam, the red pen strikes.
Now, in just a moment, I'm going to show you the examiner clue that changes the answer completely, the specific wording that flips a failing grade into a perfect score. But first, you need to see how this framework holds up when we escalate the difficulty. We need to test your understanding in a totally different context.
Which brings us to Section 3, Application Tidal Energy Stakes. Let's look at a much harder scenario.
Okay, so a tidal power station is built straight across a river estuary, creating a barrage, or basically a giant dam. As the tide naturally goes in and out, the moving water passes directly through turbines built right into the structure. Now, think about what is entirely missing from this whole process compared to the coal plant. There's no boiler. Energy resources that don't burn a fuel simply don't need a boiler. The moving water is what turns the turbine directly.
But listen, this topic isn't just about knowing the mechanics. Examiners love to test your evaluation skills here. On the plus side, tidal power is renewable and highly predictable. I mean, tides happen super reliably every single day. But on the downside, flooding those estuaries can completely destroy natural wetlands, and that heavily impacts migrating birds that rely on them to rest and feed. Plus, a giant barrage can totally block shipping routes. You absolutely must have these specific environmental pros and cons locked and loaded for a high mark evaluation question.
Section 4, Spot the Physics Error. Time for an interactive challenge. Let's see what you've got.
Now, what's really interesting here is seeing how quickly things go wrong. Read this student's answer carefully. A tidal power station uses a boiler to turn a generator directly to make electricity. Based on the definitions in the mechanisms we literally just covered, where are the fatal flaws in this sentence?
I actually want you to pause right now and predict. Think really closely about those words. If you were the one holding the examiner's red pen, what would you immediately cross out? Where are those hidden zero-mark traps hiding?
Section 5. Examiner Style Correction. Let's step in and rescue this flawed answer.
Okay, here is our systematic correction checklist. First things first, strike out the word boiler. We just learned tidal power doesn't use a fuel, so there is zero thermal energy transfer to steam required. Second, this student completely skipped the turbine. You have to state that the moving water turns the turbine directly. Third, make sure to clarify that the turbine is linked by an axle to the generator. And finally, delete that super vague phrase, to make electricity, and replace it with the exact syllabus terminology. The generator uses electromagnetic induction to induce a voltage.
And honestly, this brilliantly illustrates the difference between failure and perfection. A fragmented, conceptually flawed answer like the first one scores a flat 0, but a bulletproof top-band response, it reads, moving water turns turbines, turning the generator to induce voltage via electromagnetic induction. Applying our specific vocabulary is exactly what secures the absolute maximum marks on the paper.
Section 6. The unresolved problem. Because we are missing one critical piece of the puzzle.
So, you have the perfect wording now, but do you actually have the speed? Knowing this entire framework is completely useless if exam timing pressure causes you to freeze up, panic, and leave half the paper totally blank. You might have all the knowledge in your head, but without the execution speed, those marks are still going to slip right through your fingers as the clock runs out.
To fix this, you absolutely need the second half of this rescue toolkit. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations, and jump straight into our timed answer writing system explainer right now. Let's beat the clock together. But before you do, ask yourself this. Are you losing marks because you don't know the physics, or simply because you haven't learned to speak the examiner's language yet?